Good morning, everyone, and welcome to today's session on Data for Good Exchange 2021 session on a spotlight on good quality data. With me today, I have three representatives joining from Bloomberg and J.P. Morgan. Starting off to introduce you to David Hock, who is a data management director with us at J.P. Morgan, Martin Helen, who is an information engineering team lead in the CIV engineering and architecture business at J.P. Morgan, and lastly, Samuel Hunter Baxter, who is a data analyst in the third-party index team at Bloomberg. Throughout the session, please do remember to ask some questions in the chat, and we will have some time for Q&A at the end of the time. So I'll start off by handing over to David.
Thanks a lot, Ali. Good morning, everyone. So in addition to the presentation we're giving you today, there are going to be some exciting opportunities for some user participation via some polls that we have for you. So look out for those and get ready to vote. I guess before we go into the complexities of what data quality is, it's worth checking that we understand its meaning. There are lots of exciting definitions that you can find out there, but probably the one given by the Data Management International organization, which is a not-for-profit organization, is probably as good as any. So let's break it down and focus on its key requirements. So if we look at the definition, it says data is of high quality to the degree that it meets the expectations and needs of its consumers. So I guess that tells us it's not a binary requirement. Data isn't just good or bad. It definitely is a scale of data quality that we're interested in. And the fact that it's in relation to the expectations of the need of its data consumers means that it's a subjective measure. Data quality is very much in the eye of the beholder. The next bit of the definition says that is, data is fit for the purpose to which they, i.e. the data consumers, want to apply it, which tells us, again, it's not an absolute measure, it's very much relative. And for the purpose to which the data consumers want to apply it means that's independent of the propriety of use, meaning data quality is nothing to do with what the data is being used for. It's all about, is it fit for the purpose for which what needs to be used, whatever that use is. Next slide, please. So I guess before we go to this slide, let's have the first poll. What we wanted to ask you, the audience, is what does data quality mean to you? So I think we have about 40 seconds for people to select their choices. What does data quality mean to you? Do you feel it's everyone's job in the organization? Good in theory, but not practical? A tax with no business value or an overhead? Not sure, perhaps, or not my job, someone else's job. So hopefully everyone's voting frantically. We'll get some interesting results from this. Okay. So it looks like the majority of people are saying the right thing. It definitely is everyone's job in the organization. We have a few not sures, which is fine because I guess that's why we're talking to you today. And a few who think it's good in theory, but not practical. But I guess we can talk about how to make it more practical. And a tax, yes, it is a tax in the sense that it does cost to put out a data quality program out there. But again, we'll be referring to that in our deck. What are the optimum models that you can apply to get value from that overhead? Thank you very much. So just looking at what we have here when data quality goes bad, so there are quite a few data horror stories that you can find if you search the internet, as I have. And I'm not going to go into these, but these are basically spreadsheet-based errors where people have put kind of wrong values in that have had quite a massive impact when you look at some of these examples. And I think that this really highlights the risks associated with bad data. It's by no means a complete list of the types of data quality issues that you could find, but it's worth thinking about some of the common themes that come out in these examples. And I guess the first thing that stands out to me is all of these are manual inputs. Okay, so it's where people are entering data. Secondly, there seems to be like a butterfly effect or a reverse butterfly effect, because you usually think of butterfly effect as being positive, possibly. So quite a small input results in a leveraged, much larger output. The other thing to notice is you probably agree they could be easily avoided. And lastly, I think most people agree is prevention is much better than cure. So it's a lot harder to put these issues back in the box after they've been caused than just to ensure that the error couldn't have been executed in the first place. So before we go to the next slide, we've got the second poll for you. Interesting to see how clean you think the data is in your organizations when you think about some of these issues that arise. So would you say, A, I'm hoping this is not the case, that it's filthy? You spend a lot of time scrubbing data, slightly murky, you make do with workarounds. Is it clean enough? No idea, which I guess is not a good position to be in, or can you say it's pristine? So I think we've got some results coming through. Not a surprise. I don't know if our other panelists want to jump in, but this certainly kind of corroborates what I tend to see, which is slightly murky, and you have kind of what you might think of as a hidden data factory under the bonnet, kind of squirreling away, fixing data. Okay, so if we close the poll and move on to the next slide. If you do data quality properly, success doesn't always feel good, right? I think that's an important thing to point out. So it really is an emotional roller coaster. And it's important to say this and recognize this, because you need to set the expectations of your stakeholders, be they people within your own team running data quality programs, or others such as sponsors in the organization, internal customers, etc., who rely on that data, right? And what I mean by that is, if you look at the starting point, you generally have a conviction that you need to manage your data, but the confused face there, slightly frowning, kind of tells you that you think you have some data quality issues, but you're not sure how bad they are. So using the common analogy of water, you've got a blacked out cup that you're drinking from. It could contain pristine spring water, but it also could contain Chateau Thames or something in the middle, but you just don't know because you don't have the transparency. After a period of discovery where you look into your data quality issues, you start discovering the real state of your data, which can result in shock. But I guess the positive news is it puts you in pole position for taking action and importantly, getting sponsorship from your organization for the work that will then follow, which is remediation. And then, of course, after all of that hard remediation work comes the euphoria that you get from having confidence that your data is pristine. That's not the end of the story, though. It's worth pointing out that this is a cycle rather than a one and done exercise, because the business continues, change continues, and data is always changing. The other thing worth pointing out is different parts of your organization may live on different parts of this journey, right? And therefore have different emotional states, right? And that's a good thing. It means parts of the organization that haven't yet started or are in the early stage of this process can learn from those that have done it already. So we've looked at a fairly pessimistic view and the horror stories of how data can go bad. Let's look at the potential upside for good data. And we see some examples here. So these are key opportunities where organizations and crucially the decision making that needs to happen can benefit from good data. So for instance, for regulation, this is, I guess, less of an upside, but you clearly have to make sure if you're a highly regulated organization that you're able to comply with regulatory requirements. In the operations space, in order to optimize efficiency, you need to be able to accurately measure your current state and know where your operation currently is. Any opportunities for growth that involve change enablement will rely on you understanding that current state as well, and clearly being able to measure along the way how that change is progressing. In the innovation space, when we think about AI or machine learning initiatives, you know, we hear about, you know, garbage in, garbage out, and we know that the failure rates with AI type initiatives are very often to do with bad data inputs. On the strategy side, whether it's threat management or exploitation or segmentation of your offering, again, you need to understand customers, you need to be able to size those threats in order to make decisions. And then lastly, again, on the customer side, you know, we very much these days talk about personalizing customer experience, and that, you know, relies clearly on understanding who your customers are, which requires good data quality. Okay. So at this stage, I will hand over to Martin.
Thanks, David. Thanks a lot. So I'm going to return briefly to the definition for data quality that David mentioned a few minutes ago, and that's the Dharma definition. So I'm actually going to delve a little bit deeper and talk about what we need to know about data to be able to start your data quality journey. So can you move forward, please? Thank you. So the first thing you need to know is what data are you talking about, right? You need to know what data you have, and you need to be able to categorize it so that you can identify it, discuss it, and obviously plan and set the scope for what your data quality exercise is. And clearly, after you've got an idea of what your data is, you need to know where it is. So where does it reside? So to test and remediate data issues, you need to be able to locate it. And this can mean locating it down to individual systems or components, or know where it is in terms of a database, or even files and Excel sheets. The next thing you need to know is who are the data consumers, because referring back to the definition of data quality here, data is of high quality to the degree that it meets the needs of the consumers. So it's the consumers that really define what is good for them. And you need to care about the data quality in the data stores and the places where they actually use that data, where the data's landed. So sorry, just going back one step. So I'll mention again, different consumers have different expectations of the same data, and consumers are often producers. So you end up with pipelines of, you know, a consumer producing some data for another producer and so on in a chain. So it's very important that you can trace data through these pipelines to be able to locate it. But thanks, Sam. Yeah, if you can move to the next slide. So this one, I'm going to delve into a bit more detail into some dimensions of data quality. Three big ones: completeness, accuracy, and timeliness. And then there's three smaller ones, 6 in total. The three smaller ones are uniqueness, integrity, and consistency. So if you can go to the next slide, please. I will talk about completeness, if you can. Thanks, Sam. So completeness is, I'll give you a good example. So let's say you want to do a mail shot to people that are donating to your organization. In order to be able to send out a letter to them, you need an address, and it's not sufficient just to have a postcode. You'll need the first line of the address too. So for a consumer that wants to do a mail shot, completeness to them means that they need a full address that you'll be able to send a letter to. However, another consumer that wants to do some analysis of geographically where donations are coming from might only need the postcode to be present, and that's sufficient for them to do their analysis. So completeness is different depending on which what your consumer requirements are. If you can just step forward one thing, Sam. And I'll talk a little bit about uniqueness here as well, because it's somewhat similar. So uniqueness is when you want to check that some data is unique within the context of a set of data. And this normally is done by checking the data when it's at rest as opposed to in motion. And what do we mean by that? So data in place, data at rest, is data that you store in a database or a file somewhere. So you have a large set of data against which you can check uniqueness. Data in motion we use to refer to data that's moving from one place to another, so a feed of data. So to give you a concrete example, if you've got an overnight feed that comes from an organization that says, here's your new customers, there's not much point in checking for uniqueness on that feed overnight. It might only have 4 new customers in it from the previous one. What you want to do is you want to take that new customer data, and when you try and insert it into the spreadsheet or the database or whatever that you're using to record all your customers, that's when you would want to check the uniqueness. Accuracy, if you can flip forward one more, thank you very much. So accuracy is about whether the data is correct, but there are a few subdimensions that are worth exploring here. So the subdimensions are conformity, validity, and correctness. And correctness really means, is the data that you've got completely correct with respect to the sources that you have? And that can be very, very expensive. It requires like a full reconciliation. So I can give you a couple of examples of conformity and validity that are easier and less expensive to check for. And you can get an awful lot of progress in terms of data quality by checking those 2 things. Do you want to just advance one more, please, Sam? So in the top right, I've got some examples of some data in a mocked up database. So let's talk about conformity first. So if you look at the first 2 lines in the table in the top right hand side, so here we're saying that ABC is good, whereas the pound is wrong. So in this example, what we're saying is that you've got 2 records, Holmes and Watson, and ABC is good because we're expecting the second column to be 3 strings, 3 characters, and we're not expecting it to be a special character like a pound sign. So in this case, we reject the Watson record because it doesn't conform to the specification that says you must have 3 strings in this place. And that's actually slightly different from validity. So for validity, I'll look at rows 3 and 4. Now in this example, Cagney's got a currency of EUX and Lacey's got euros. Now EUX looks like it conforms to the specification. It's 3 characters long after all, but it's not a valid currency pair. So although this data conforms, it's not valid. So that's a slightly subtle difference, and it's important. And then finally, in the last two rows here, we've got Laurel, and you can't see it from the example, but I would say infer from this that you would do a reconciliation to the data that gave you your Laurel lines in your database, and you might find that you've got two rows in your database, one of them which says Laurel has got GBP and the other one says Egyptian pound. You might then go back and reconcile the full data set to your source of data and realize that the GBP entry was wrong. So that's a lot more expensive, as I said. So timeliness. Timeliness actually has a, you can peel back the onion on this one. At the very top level, you can consider timeliness of data to mean, was the data delivered on time? If you have like an SLA with a producer of data that says you're going to get a file every day at 5 p.m., clearly if that data arrives 2 days late, then it's late, and the timeliness may affect your data quality. So also, you may receive the data on time, but the data itself may be stale. If you advance one more, I can talk through some examples. So let's imagine that you received a feed of data last night on time, but it turns out that the data you got was from a prior quarter end rather than month end results. It might be even more subtle than that. You might find that the data that you got was largely accurate for last month end, but only a few columns were stale and from the previous quarter. So that's what I mean by peeling back the onion on this one. Timeliness can really impact data quality in a few unexpected ways. So with that, I'll hand over to Sam. Thanks for that, Sam.
Thanks, Martin. Okay, so I think one of the key things to look at here is how can we actually try and achieve this data quality? And a prerequisite to this is generally to look at how we can clean the data and pre-process the data. But before we dive into that, we are going to go to our third poll question. So if we could pull that up, please. So the third poll question is, on average, how much project time do you spend on data cleanup? Do you spend 0%? Maybe you don't have enough resources. 20%, 50%, or 80%? Give it a couple more seconds for final results. Great. So there's a reasonable distribution in the middle. It looks like there is a relative amount of thought that goes into data cleanup across this, but most people are falling into the 20% category. One thing that I want to touch on here is spending effort and time on data cleanup is actually really, really key. And this is something that you will see across a lot of data analysis, machine learning, or AI projects, where there's this concept of the 80-20 rule, where 80% of the work and time is actually spent on collecting data, formatting data, and cleaning the data. So it's very common to find that you will spend a lot of your time in this pre-section to your actual analysis or your actual process that you're looking to get to at the end, where you're just trying to manipulate the data into a way that best suits the final use case and also removes anything that could be a hurdle. So how can we actually look at doing this, and why should we do it? One key thing that's really important is duplicates in data can skew your analysis, and it does cause inaccuracies. If you start counting things multiple times in some form of analysis, or maybe you've sent out a survey, you had multiple responses back from the same individual, realistically, if they're the same, you want to drop them. And ultimately, even if they're not, maybe you want to look at, is this a duplicate entry because it's the same individual who submitted multiple times? Additionally, sparsely populated data, particularly when dealing with larger data sets, can cause issues. You may have missing values that are really important and are absolutely mandatory. And this goes back to the completeness of a data set and really defining what is mandatory for what you're trying to achieve and what is optional. And where you've got gaps in mandatory data, it can cause a problem. Another thing that I want to highlight is superfluous data. I work with large volumes of data on a daily basis, and within these data sets, some of the information isn't necessarily relevant to what I'm trying to achieve. So this superfluous data actually detracts from the focus of the task at hand, and it can cause a problem there. If we start processing this unneeded data, it also then impacts on the performance down the line. And this can cause bottlenecks or issues further if you just have unnecessary data that you're clogging up your analysis processes with. And then finally, duplicates skew analysis and cause inaccuracies. So, no. Yeah, let's just move on from that one. But how can we clean through pre-processing? So one thing we can do straight away is drop duplicates. Duplicate data is just unnecessary noise, and you really do skew results when you count these things multiple times. So as a really quick example here, imagine we've sent out this survey. Mary, Joe, Sophie, and Bill have replied, but Mary's actually responded twice. So I can see Mary's got the same email address and she's provided the same answers. There's no reason to count that 2 times. We can just remove Mary's second answer. We can also get rid of the irrelevant data points. So this is really important that you know your data and the problem you're actually trying to tackle with that data when you come to this form of data cleanup. The key piece is that if you know something has very little bearing on what you're actually trying to achieve, you can remove it. Don't spend the time processing this data and just drop it because it distracts from the use case. So taking the survey concept again, let's imagine I'm running a survey and I want to poll to people who drive. Okay, so we've got a couple of questions. Do they drive? Do they drive a manual or an automatic? And also our data set contains a column of do they like cats? Realistically, whether these individuals like cats or not isn't relevant to the use case, and it's just going to cause unnecessary headache down the line, especially if you try to capture these data points that aren't relevant and make use of them in your analysis. So we can refine this down and say cats aren't relevant to driving. Let's just drop that column and we can ignore it. And then one of the major problems is the sparse data. And this is always a difficulty to handle. And there's not one strong way to go about it in every time. You have to really review your use case at hand and decide which makes sense in that scenario. The most straightforward manner is to drop rows if it's necessary data. So again, this looks back at the mandatory piece. Maybe we were running a survey and I wanted to get a sense of individuals who are married and do some analysis into them. Now, if Bill's filled in this survey, but he hasn't indicated whether he's married or not, I can't use that piece of data. And there's not really anything you can do there except discard it. He hasn't given us an answer either way, and there's not really a way we can infer yes or no from any other data points here. So we can just drop that row and continue the analysis with the rest of the data set. Another way to handle sparse data is to look at the numerical values. So potentially we're missing a numerical entry within one of our tables, and we can look to populate that with an average. You can use a mean, you can use a mode, you can look at other methods if you so wish, but here, let's say Sophie hasn't responded how many children she has, and perhaps we're going even more granular and saying, I want to do research on married individuals who have children, or I want to know about how many children. And maybe we can predict here with just a simple average and say, okay, there's 4 children between the other 3. So taking the mean, Sophie should have 1.3 children. But then I think the key thing here is to really take your use case into mind, because 1.3 children doesn't really make sense. And realistically, if we take the mode, we actually get 1 child. And in this case, that's a far more realistic value to populate the gap in the data with. So it's really important when you're filling in numerical values with an average that you actually review what that category is, and the choice of how you take an average is use case relevant. And then finally, with gaps in data, we could look at categorical data types. Categorical data is harder to actually populate with a meaningful value. So a lot of the time it's sufficient to just look at this and say, okay, I don't want an empty entry. I'm just going to assign a unique label and say this is unknown. And then everywhere within that column or category where a value is missing, you just put in this unique value and you just leave it as unknown. And down the line, when you're actually doing analysis or you're actually processing in an automated manner, it's a lot easier to deal with a standardized string value than it is to handle empty gaps. Alternatively, if you want to put more effort into this and you've got the capacity, you can look at predicting these entries. So you can look at methods like linear regression or even neural networks to process through categorical data across the rest of the data set and actually predict what these entries should look like in the gaps. From there, I'm going to hand back over to David, I believe, to talk about authoritative sources.
Actually, it's Mark on this one. Thanks, Sam. So I'm going to talk a little bit about architecture here, which might not be immediately obvious for less technical practitioners, but a common pattern that we've seen in our careers repeating that sort of comes about by default if people don't think about things up front is what we call this point-to-point style of knitting together your data processing tools, components, systems, whatever you want to call them. So you can advance one, please, Sam. In this point-to-point style, what we've got here on the left-hand side are three transaction systems, imaginatively titled transaction system 1, 2, and 3. But they're all systems that are producing transaction data, and they're the systems of record for that transaction data. So what that means is that when people record transactions in system 1, that's the system that data is managed in. And when they do it in transaction system 2, it's another completely different transaction system, possibly with a slightly different representation of what a transaction is, possibly owned by a different company or a different part of your organization. And what happens is that if in an organization you want to analyze all the transactions that are coming through, and you've got 3 consumers downstream that do sales reporting, inventory, and accounting, the examples I have here, they are often hooked up to every single transaction system. So now every single transaction system talks to sales, inventory, and accounting, and vice versa. And what this means is that all the systems that you see here are tightly coupled to one another. And it means that the data consumers actually have to implement different analytics and feeds from each system of record. On top of that, the data quality definition for the data coming in is different for each one of those lines, each one of those point-to-point feeds. And even worse, the operational process is different for each point-to-point feed, because one feed may come in Friday afternoon, the other one may come in nightly, et cetera, and they come in from different places. And the problem with this architecture is that all the data consumers need to know all of that. They're coupled to the producing systems here, and they need to care about their differences. If you can move to the next slide, please, Sam. Thank you. And so we have a concept of authoritative sources, and really it's quite simple. The concept is that if you have a set of consumers that care about transactions, and it could also be a set of tools and analyses you do in your charity that cares about 100 different types of donors, for example. Rather than running and coupling sales to each transaction system, you introduce this middleman who you will aggregate transactions into the authoritative data source. And crucially, you'll map those transactions into a common model for transactions, i.e. the data that you need for transactions downstream in your sales, inventory, and accounting consumers. If you can punch forward one more, please. And what this now means is that the similar data from the different systems of records is aggregated in one model in a single authoritative data source that all of your analytics are now running on. So that means you can reuse your analytics. It means that the consumers don't care about all of the operational processes for all the transaction systems. They just have to connect to the authoritative data store. And it means that you can apply one common data quality standard to all the data that sales, inventory, and accounting are using. So with that, I'll hand back over to Sam, because I think he's got a sort of a more in-depth use case where it explores some of those concepts.
Cool, thanks, Martin. So this is going to follow on somewhat. It's a similar use case, but it's going to outline, how we actually tackled a specific problem. There was a case where we had some data and the identifiers are inconsistent. And this is quite common when especially you're working with data that you don't generate yourself. If you're dealing with external data, you have no control over how people identify or tag values. And a lot of the time, you might have many documents that contain the same data. But if they're from different sources, they may be identified in different ways. Because of this non-standardization of column headers and identifiers, you actually kind of want to find a way to streamline this and consolidate everything together. Because if we can have everything combined, when we know it's the same data, we can apply the same processing, analysis, or workflow downstream. And this just means we can spend one piece of work implementing a generic solution for the actual analysis, the processing, and then just feed in a standardized set of data that has been tailored via our cleanup process beforehand. So to take a basic example here, let's imagine we just had full submissions from different users, but they've created this data themselves. And we requested a value and Mary decided to call this a value, whereas Joe went with number, Sophie chose sum, and Bill chose count. Now, we know that this data all represents the same thing, but it's difficult to build bespoke solutions for every different individual's submission format. So we want to look at a way that we can actually consolidate this, and we can say all of these actually just represent a total. And we can go from there and say, so how can we actually implement a solution that will perform this consolidation? And one of the ways that we can do this is through a pre-processing handler service. So this separates the cleanup and any reformatting from the actual processing and analysis. And it completely removes that section so that you can tailor it to deal with the problem at hand. Then you ensure that you've reduced the load on the intensive downstream operations because you've removed unnecessary data and you've bundled everything that's like for like together. And you also ensure a consistent input. And through a consistent input, you're going to get a consistent output. And this is really, really key for any streamlined workflow, is that we can just consolidate at the highest level to make it as easy as possible for our downstream analysis or data publishing processes. So let's build this out a little bit and make it slightly more complex. Imagine this time they've each submitted 4 different values. Now, one of the ways we can consolidate this is with a really simple mapping table. And this is quite quick and easy to put together, but it's actually really effective. If we know that they're going to continue submitting similar data to this, and we know they always use these same identifiers, we can take an inventory of them and just say, I'm going to take value, number, count, and sum and map it to total. And A, B, and C, I know actually are representing value X. D, E, F, G represent value Y, and so on. And we can then consolidate all of these different identifiers through this mapping table and output a final piece of cleaned and transformed data that is now consolidated for our downstream processes. So what are the challenges, and are there any alternative solutions? I think one of the key things when you have problems like this is there's not a one-size-fits-all solution. This will vary based on the size of the data set you're dealing with, how many variables are at play, and it can get very complex. But direct mappings are actually really effective if it's a small data set, or you know that once you've done this mapping one time, it's very rarely going to change. So this can actually be sufficient in a number of use cases, and it's quite cheap to implement, and it's really simple. But if we have a large universe where we don't know the identifiers, we can't reconcile them easily, it's not realistic. At that point, you do need to look to more complex solutions. So you can look at NLP to intelligently identify like-for-like data points, but this is very costly and complex. And any scenario like this, it really is a balance of weighing up how difficult is the solution to implement versus what is the actual gain from that. And now I'm going to hand back to David.
Thanks, Sam. So if we continue on the topic of data quality solutions, how do you actually implement, and what do you do in your organization? So I guess it's worth thinking of these in three verticals: reactive, proactive, and preventative. And I guess it's worth saying also that any well-planned and managed process for improving your data is good, whichever of these you select. And whichever you do select really is also based on a cost-benefit consideration. So if we look at reactive data management, the initial cost in investment, and this is investing in a reactive data quality control, is relatively low. And that, I think, makes sense when you think that reacting to data quality issues is a case-by-case action. So basically, you know, once each horse is bolted, someone goes back into the field to retrieve it. Okay, so clearly, you know, it's very bespoke. It depends on the problem that you're faced with. But having an army of people on standby to do this would be very costly and probably not very efficient. And the remediation cost, if we think of that, and if we think back to the data horror stories, Sam, if you just want to advance, can be sky high. So again, if we think back to some of the examples, the intelligence agency bugging too many phones, or the Olympic Committee having to upgrade thousands of seats because it sent out the wrong tickets, is clearly a lot more costly than the investment in a control to prevent that. Proactive data quality involves monitoring your data at opportune points in its life cycle. And the control cost of that can be low or high depending on what kind of system you put in place. And there are lots of vendor tools on the market that can help you do that. So if I take my horse bolting, if we go back a bit, Sam, if you take the horse bolting analogy, the horse has bolted, but perhaps is still in the paddock. Okay, so there is an impact, but there's a way of mitigating that. And the drivers for putting data monitoring in place are generally due to the size of your data landscape in your organization, and also its complexity. And by complexity, I mean, how long are the chains of handovers from the producers of data to the consumers of data, if you go end to end? And also, does data tend to fan out from producer to consumers? So do you have, you know, few production points feeding many consumption points, meaning that you might want to catch data quality issues upstream in order to prevent quite widespread impacts? And then finally, preventative data quality, I think, means what it says on the tin. You're preventing bad data entering your production environment through a number of different approaches, which could be designing your systems with a data lens, or creating processes with the right training, or maybe it's your change management process that needs to be upgraded. So your software development lifecycle needs to have more of a data focus, so that these kind of bad data processes or system components don't get released in the first place. Next slide, Sam, thank you. So which of these is the best approach? Well, the answer to that really is all three. It's a hybrid model combining reactive, proactive, and preventative. So if you can, you would start with your preventative approach. So any bad data that's trying to make its way into your organization through manual input is not allowed to get through, but typically some will, right? Because you will be learning about your data, which will be changing over time. Okay, so you're always kind of one step behind with that. But any data that does get through, you would then try and monitor, probably as upstream as you can catch it. You might use AI or machine learning, which is kind of an exciting new thing in this area, and other controls that you might have in your organization already, like reconciliations, also serve as good data monitoring. And then finally, any data that does get through and crystallizes as bugs in your processes, you would then apply a rigorous data quality issue management process to get those remediated. And I guess finally, important thing to point out is a positive feedback loop, if you progress, Sam, which means that issues that you find in your data allow you to create better controls that would enhance your proactive data quality process. And similarly, any data quality monitoring that surfaces data quality issues at source then allows you to go back and informs you as to how to redesign those systems and processes so that they don't reoccur. So lastly, I mean, you've heard a lot today about data quality. What are the top 10 key takeaways that we would want you to go away with? So to summarize, define a model for your data, incorporate data validation within that model, identify your systems of records, so the systems that create data and the data they hold, and then try and aggregate that data in what we call authoritative data sources, so aggregation systems for any onward distribution, data quality monitoring, and any analytics that you might want to do so that you've got everything in one place treated in a standard way. We talked about data quality being in the eye of the beholder. So the consumer basically defines what data quality means. So you need to identify who those people are and understand their needs. Establish controls to prevent the creation or the acquisition into your organization of bad data in the first place. Further clean any data of concern in pre-processing, so in the preparation of data. Number 7, if you have the investments to put into this, always try and establish a data quality monitoring process for early detection. Again, you know, prevention is better than cure in all cases. And where those bugs do arise, you need to have a rigorous data quality issue management process to address those. So you need to be able to identify where those issues are arising. You need to be able to do root cause analysis to find out where they originated. And then you need to have a process and the budget for fixing those data quality issues. So number 9, that talks again to the root causes, and then the virtuous feedback loop that we talked about in the slide before this. You need to have like a learning mechanism in place. So at the very least, when bad data does arise and has an impact, it's something that we can learn from and try to prevent reoccurring in the future.
So we're getting through lots of great questions here, but in the interest of time, we'll try and summarize a few. So Martin, you were talking about completeness, accuracy, and timeliness, and we've been asked, what would you say is the most important aspect when kind of weighing those off?
Well, not necessarily the most important, but certainly the most frequently occurring issues that I observe is around completeness. So if you were to ask, take a survey of the data quality issues in any big org, I bet that would be the same. It would be that the data that is required for a particular job is not there, right? And that's the biggest challenge. Timeliness, the answer is it depends, because often you can get away with using stale data. It depends what you're doing. So, you know, for example, if you're doing some analysis that requires some averaging, then using reusing yesterday's or the day before's data, if that averaging is over several months or a year, it's not going to have a huge impact. And in accuracy, again, it comes down to really what is, if you have some things that are particularly sensitive to what you're doing, then yes, clearly you need to ensure that the accuracy is there. Again, if you're looking at means and averages and distributions, individual errors can be more or less significant. It really depends on the use case.
Okay, great. And Sam, this is a question for you. As you were talking through an example there, would you indicate where you populated a data field with a mode or a median value?
So I think that's use case dependent. Like, if my downstream services need to know, then yes. But a lot of the time, as long as you're aware, I don't think it is overly necessary. It really depends on your use case. You know, if you really have important, the more important this column is, basically. If it's a really key factor to the analysis you're trying to perform, yes, indicate. Because then you need to be very clear, you know, like this section has had median, mode, means included. If it's one of the lower impact fields within your analysis, it's just supplementary data. For example, if you're building out, you know, a neural network and it's just one of many dimensions and it's not weighted too highly, it's not as relevant. It really does. You need to review your use case and know your data. I think this is one of the key, like really key takeaways for me from this, is knowing your data and knowing the problem is so important with all of this. So as long as you know that it's important to you to identify this downstream, yeah, definitely. But if it's not, then it's okay to just let it go.
Okay, great. And David, you were mentioning about AI and how you can leverage AI within the data quality workflow. Are there any kind of tools or techniques or tips that you could share with us on how we could use AI going forward?
Yeah, I'm not going to sell any particular tools, but I would say that the typical approach has been up until now for people to write data quality rules. Okay, and for that you need teams of people that understand the data, which is fine because you should understand the data anyway. But you then typically need a team that understands how to use a particular vendor package and write SQL to find your data quality issues. The downside of that is that tends to be quite slow to market. And we know that data shifts over time, so that as that data shifts, if you don't maintain your rules, you start to get noise in your results. Now, there are some very exciting approaches that we see with AI, which mean that you can use stochastic type approaches fairly out of the box with very light configuration, rather than relying on deterministic data quality rules. And that means that the effort involved in maintaining that validation process is a lot lower, and you can start looking at your data quality issues a lot quicker. So it typically doesn't give you 100% of the answer, but even 50% very quickly means that someone can go away and start fixing.
And then we have another question here around superfluous data. So Sam, I think we were talking about that, and how do we actually identify that? Is there a process that we go through, or could you give us an example?
Sure. So this is quite a difficult one to do programmatically, because it's quite you know, a human response. You know the data set, you know the problem you're trying to solve. You need to review everything and say, okay, this is the focus that we're looking at right now, and go through your data. Like before you start any attempt to actually clean up the data, make sure you know what is in the data set, and then review and say, does this data that I've been provided seem relevant to my problem? And you can infer from there. I really think this is a case of inference, where okay, use case, on my side, we receive a lot of data. Now, all of this data is bundled together, but personally, for my work, I only care about a very small amount. So I will review, you know, a sample of the data set before I start any analysis, before I start any processing, and just say, okay, I care about these columns, I care about these fields. And then one of the very first steps in my process will be to drop anything that I do not care about. And it's just knowing your use case. Again, it all boils down to know your use case and tailor your data set input to meet the needs that you're trying to achieve.
Okay, great. And one last question. Martin, you were talking about how different consumers have different expectations. For a non-profit use case, for example, fundraising, what would be kind of your key takeaway for data quality?
So it would be getting a very clear understanding of your users' requirements, and bear in mind that sometimes they may be competing, and so getting a solid understanding of what different users require and figuring out how to satisfy all of them is something that if you do up front will save you a lot of pain. And I can give you some examples where if this isn't clear, if you don't have a clear description of what the data is and that you're supplying to lots and lots of users, you may find that one consumer says, well, this column must absolutely be present and say the following things. And then another consumer may say, this column must absolutely be present and say these other things, because there isn't a clear definition of what that data is, and they're using it in different ways. So that's why I think it's super key that you have a very clear definition of what the data is and what people are using it for and why. Great.
So we're nearly at time. So that just leaves me to say thank you so much to Martin, David, and Sam for your insights and for a very informative and engaging session. And please be reminded that we're only halfway through the data journey. We have lots of exciting sessions coming up, and it gets even more exciting from here. And lastly, do remember to dial in to the closing session hosted by Gideon Mann from Bloomberg on Thursday at 3 p.m. With some of our non-profit organisation counterparts. It should be a really exciting session. So thank you so much all for your time.